All right, everyone. Welcome back. Um, so I want to share a few things that I learned today while preparing. Um, so one thing is, how does in a hypothesis test, right? How does changing the alpha levels affect rejecting the null hypothesis or not? I mean, rejecting whether we decide to reject the null hypothesis or not. So if alpha is 0.05, sorry, if alpha is, yeah, 0.05, um, and you're assuming a normal distribution, a z test, uh, and it's a two-tailed test, then your cutoff values for the z is negative 1.96 to 1.96. In other words, if the test statistic lands um, you know, greater than or equal to 1.96 or less than or equal to 1.96, then you reject the null hypothesis at alpha 0.05. Let's say you increase the alpha, right? Because alpha is probability of type 1 error, right? And so let's say you increase alpha, so you increase the probability of type 1 error. That just means that you're increasing the chances of you rejecting the null hypothesis when you shouldn't be rejecting the null hypothesis. So it becomes easier to reject the null hypothesis when you increase alpha. That means that the critical values, so let's say we change it to um, 68%, you know, yeah, if we change it to 68%, so no, sorry, not so let's see, 70 is 0 0.3, 68, 31. Yeah, so let's say alpha is 0.31, right? So that's 0 point, no. 60, 70 is, you have 30, so 15, 0 0.16. Yeah, 32, 60. Yeah. So let's say alpha is 0 0.16, right? So now there is, um, what am I saying? 5%, yeah, 0.32. Yeah. Let's say alpha is 0.32, then on each end you're gonna have 16% chance at 0.16, 0.16. So basically moving it in, and that will be z-score of -1 to +1. So you're making it easier. So if you get a test statistic that is past those values, greater than +1 or less than or equal to -1, then you're going to reject the null hypothesis. So it becomes easier to reject the null. Now, let's talk about the t-statistic. T-statistic is used when your sample size is small, right? And the reason, conceptually, right, the reason why you want to use a t-statistic when the sample size is small is because the sample statistic can vary more when you take a smaller sample size, right? And so we need to take into consideration that variability. And so there's a lot more uncertainty with small sample sizes because we don't know how accurate it is because of the variability. Um, and so what we do is we make it harder to reject the null hypothesis when compared to the z test, even at the same alpha levels, right? So for example, when alpha is 0.05 for a z statistic, the critical values for two-tailed z test is negative 1.96 to positive 1.96, right? Of course, t-test takes into consideration the sample size, and you got to go to get the degrees of freedom, which is the sample size -1. But basically, it's gonna have fatter tails and lower height at the center. What that means is, in order to get probability of rejecting the null at 0.05 level, you're gonna move the critical values out more, right? Because the tails are fatter, right? So to get cover 5%, you need to move it out of the curve. And what that practically means is that we need more and more extreme test statistic values to be able to say confidently we reject the null hypothesis. So that is the gist of t-test and t-statistic. And to be honest, I think that's all I kind of need to know about that. And generally, when the sample size is greater than or equal to 30, people just switch to the z-statistic, z-test. But then again, it really depends who you talk to. Some say, yeah, they want to be more conservative, and then use a t-test until sample size is greater than or equal to 100. So it really depends on what you how comfortable you are there. But t-test tends to be more accurate if you're not sure of the population standard error, right? It's more conservative. So I don't know about accurate, but it's just more conservative. But then if the sample size gets big enough, then you can just use the z-test, even if you don't know the population standard deviation of the distribution. Yeah. All righty, well, I'm going to sign off there. Bye.